we're going to start. Remember, I told you, you better understand the equation so far because we're going to add one more term to velocity, two more terms to acceleration. Yeah. Okay, so let's see if we can do that derivation today. So basically, this is what is known as the relative motion. Okay, so in this case, in order to show you what is the difference, we're going to look at one very quick example. So let's say you have a bar, and inside the bar you have a groove, okay? So that means that this point over here can move along the bar. Agree? Okay. And now let's say we have here another bar, which is just like the ones we have been using all the time. This is a solid bar. So just for the sake of brevity, let's say we call this point here A. Let's say this point here B, and this point over here C. Okay, so let's start just by the velocities, and then we see that will be different. So what is the strategy? It's always to start from one point where you know the velocities and to try to find the velocity of one point from two different locations. So in this case, we can find the velocity of which point from which two locations?
A from B and C.
A from B and C. So let's say, let's do the one we always do. So let's first find velocity of A from point B. So this would be equal to what? VB plus omega of the bar AB cross S of A with respect to B.
Yeah.
VB is 0.
VB is 0, correct.
Yeah.
So now the problem is probably gonna have something new. Let's try to find the velocity of A from point C. So this should be equal again to VC plus what? Omega AC cross S of A with respect to C.
Yes.
But now,
AC changes.
okay, so that's very good, perfect comment. So you see that AC is not fixed because this point here is not fixed on the solid, correct? So all the points in this bar over here, AB, since it's one solid, they all move with the same velocity and same acceleration. In this case, this is not the case for bar AC, no? So you're going to see here that it should be one extra term that is called plus velocity of A with respect to C. So you agree that A is going to be able to move along the groove with respect to C, no? Okay, so here we have this extra term. So obviously the math should give us that extra term as well. Okay, so let's do the derivation. All right, this is the one for the acceleration, which is, oh wow, that's not, I wanted to do that one small line. Okay, it's fine. Let's just do it big. So in this case, we're gonna have here X and Y. And we're going to call here now this point here. So let's say this would be point O. This would be here our point A. You can do it at the top. So it will be B. So this vector here would be S of A, this will be S of B. And now this one, well, this one would be position of A, S, A, B. But I'm going to add one more thing over here, is that I'm going to add here a new reference frame that we're going to call X prime, Y prime, O prime. So that the O, X, Y is generally what is known as the fixed reference frame, and the O prime, X prime, Y prime. We're going to call that one the relative reference frame. Okay, and this object here can be moving with, let's say, an angular velocity omega. Okay. So now we're going to find the velocity. So let's first do the velocities. So we can go through the vector A with the ds A dt. Or we could do what? D dt, which is what we did the first time, could be equal to SB plus S of A with respect to B. Let me, before proceeding, I'm just going to check one thing. Okay. So basically, this will give you dsB dt plus this of A with respect to B dt. And that's where everything comes here a little bit different, okay? So this first term over here is going to be VB, is not a problem. But now this one, okay? If you remember before, I just said this is equal to omega cross R. But in this time, what's happening? This is the same as point A, okay? This point here is going to move relative to point B, no? It's not going to be fixed like before, okay? So the math needs to show us that. So now I'm going to rewrite this equation here. So I'm going to call this one X prime A I plus Y prime A J plus Z prime A K. Okay, and this is going to give what? VB. If you take the derivative of a function, what is the derivative of a composite function UV? Is
U prime V plus U prime U.
perfect. Is U prime V plus UV prime, no? Okay, so we're going to do exactly the same thing right here. So this should be equal to what? dx prime A dt I plus d v prime A dt j plus d z prime A dt k plus x prime a di dt plus y prime a dj dt plus z prime a. Again, I mean, I do the derivations in details, but I'm not expecting that you know how to do the derivations, okay? You need to understand the final equation. You need to learn how to do the derivation. This is more grad school. It's when you need to have a better understanding of the material, no? Okay. So now, what is the physical meaning of this term? What is dx prime a, dy prime b, dz prime a are?
Change of position.
So is the position, is the change of position of A with respect to B. Correct? All right. So this will be really the term velocity of A with respect to which point? B. Okay, so if we start looking at this equation here, okay, we needed three terms. So let's say we have, it's a little bit different in this case, but let's say we have here 1, 2, 3 terms. So we have the term of this one here, VB, that could be fixed, plus the one relative, and all these terms, this one should be equal to what?
Rotation.
Should be equal to the rotational, no? So really, I'm going to write it down, and then I will give you some more detail, but really this term over here should be equal to omega cross what? S of A with respect to B. And I'm going to tell you why it's equal to that. It's not that important that you understand it.
Professor, would that be omega AB? Or is that just?
Will be the omega of this one here. Okay, you want to call it a B, yes. This is the rigid body. This is you looking from the outside. Okay. Okay, so why is this equal to omega AB? Okay, so it's easy to see on the equation that on this equation, so S AB really is equal to what? X prime A, Y prime A, Z prime A, no? Yeah, that's not complicated to understand. Okay, now what is a bit more difficult to understand is that let's say here, let's say DI dt. What is that? So if I do a figure, again, this is not important for you to understand it. I mean, to know how to do it. Understand it, yes, I think you can understand it. It's not that complicated. But let's say you have here a coordinate system. Let's say this will be X, Y. And now you're going to rotate this one. So you have over here, let's say X prime. Y prime. Okay, maybe. So what will be this one here? This is d theta dt, which would be the whatever angle you change in function of time, no? Okay. So again, so we could say that this is a little bit more complicated, but di dt would be equal to, let's say, the change in angle in, but the change of angle is moving on the z direction. Okay, so here comes the stuff. Again, I'm going to write it down once. If you don't fully understand it, it's fine. So what is d omega dt by definition?
Omega angular velocity.
Is omega, no? Okay. Omega is rotating about which axis?
Z-axis.
About the z-axis, or what will be the k-axis, no? Yes?
Yeah.
Okay. Now, if we use the rule, I'm sure you have done this. I don't know if you have done it. I think you have done it, but let's say you have here I J, and K. And then you have this rule. I mean, you can do it in the direction, but let's say this is positive. So have you seen that one before? So for example, if I use this, what do you get if I do R cross J will be equal to what?
Okay.
Okay, if I do, let's do an easy one, J cross I, J cross I will be equal to what? Negative K, no? Okay, so you see, we know the omega, d theta dt is omega, correct? Which is supposed to go on the K. But we need here J. So what should we do then?
Positive AI.
We can do cross what? What will give you J? K cross J will give you, sorry, K cross I.
Yeah.
Sorry, we need J. So K cross I will give you the J, no? So this is equal to the J over here. So that's why you see really that this term over here, the d omega d. So basically, what can we say? So that again, if you don't fully get it, it's not a problem at all. Is that this one could be equal to what? D theta dt, dj dt, dk dt. Even if you don't fully understand, does it kind of make sense? Okay. So that at the end, and this is what you need to understand, we're going to have VA is equal to VB plus velocity of A with respect to B plus omega cross S of A with respect to B. Where what's important here to know is that, remember, we always say that the motion can be divided into translation and rotation. Okay, so we need to have translation and rotation. So VB is what? What type of velocity it is? So this is but it's translation, no? Translation of B, and here WRT means with respect to, and now I want you to let me know about with respect to which reference frame.
That's what the original.
The fixed reference frame with respect to O, X, Y. Is you looking at the object moving, no? Okay, now velocity of B with respect to A. What type of motion would that be? Would that be rotation or translation? Think about here the groove. This is moving in what? Translation. So this is again translation of B again. Of B, but this time, since it is with respect to B, B is the origin of which reference frame? Of the relative or the moving reference frame, no? Okay. In the O prime, X prime, Y prime. So these two terms represent the translation, no? Two terms due to translation. And now at the end, obviously the omega cross S of A with respect to B will be what? Rotational velocity of A with respect to which reference frame?
The fixed.
No, with respect to what?
Oh.
A would be rotating with respect to which point?
Oh,
B, which is the object moving, no? So we be the O prime x prime y prime.
Question.
Yes.
So in the equation, you have VAB, and then below you have VBA. then
Oh, okay,
It's gonna
sorry.
be the same thing, it's just. the
No, it just me that, I don't know what I was thinking. This should be, if I have here A, this should be VAB. At least because I was looking at this figure here, okay, at the previous figure.
Bless you.
Okay, so now we have 3 terms and not 2 terms. Okay, so here is my trick. I mean, trick, it's not my trick, okay, it's the way to look at it. So the problem now for you is that when do you need to use this equation with the 3 terms, or do you need to use this equation with the 2 terms? So what would be the hint is that if you look over here, if the distance between the 2 points remains constant, okay, all the time, do you need this term?
No.
No, because this point will never be moving with respect to this one, no? Now, if this point here is moving with respect to the one you're calculating, so the position is not the same, are you gonna need this relative term? So for example, you see, the distance A and C doesn't remain constant, no?
You don't need the relative term.
So that means that you need a relative term. Does that make sense? Yeah? Okay, so now the bad thing is that because of that extra term over here, we're going to follow the same reasoning in order to do the acceleration, and this is going to yield to 2 extra terms. So let's do it. It's long, okay? Let you know right now it's pretty long. And we're going to have to break it into different terms. All right, acceleration. Okay, so for the acceleration, we can use the same figure over here. All right, but now we have also acceleration alpha and good acceleration alpha. Okay, so acceleration of A by definition would be equal to what?
Acceleration of V.
I mean, would be equal to
Oh,
dVA,
dV, okay.
ddt. Let's start by the basics,
Yeah.
okay? But I agree with you. So now we found that dVA is equal to what? It's equal to VB plus velocity of A with respect to B plus omega cross S of A with respect to B. Okay, so let's say this would be equal to D dB dt plus D V prime A of B dt plus D dt of omega cross S of A with respect to B. Okay, so this one is very easy. Here, this would be what? Acceleration of B. All right, now we're gonna have the other term. So where if we take the derivative of this one, we need to do as before. This should be equal to what?
All right, tell me the VAB dt.
Yeah, so this will be dx prime A
Over dt.
dti
Yep.
plus dy prime A dtj plus dz prime A dtk.
You also need to add the
I mean, we're just doing this term now, okay? So now what happened? Here we need to do as before. We need to do when you take the derivative,
right,
it will be the composite one. So this will be equal to what?
That's what I was going to ask.
2 times will be d will be second derivative of x prime a dt square I plus second derivative of y prime a dt square j plus second derivative of z prime a dt square k plus what? Dx prime a dt di dt plus dy prime a dt dj dt plus dz prime a dt dk dt. Sorry for that if it's too small, but it is. Okay, what is the physical meaning of this term? If you look at the definition before, this term is kind of equivalent to this one, no? But instead of having velocities, what do we have? Acceleration. So that one should be what? Acceleration of A with respect to B. Okay? And this one before was what? Omega cross SAB. So this will be now what? B or A with respect to B. So that's a new term, no? All right, here we go. So basically from here, we can say that this term over here is equal to two terms, no? Okay. Now, the last one we need to do is this one over here. And d dt equal to omega cross S of A with respect to B. This will be equal to what? D omega dt S of A with respect to B plus omega cross D of S of A with respect to B dt.
Where did is there no cross product on the first?
Yes,
one?
yes. And on the second one. Yeah. I put on the second one, didn't put on the first one. I don't know. Okay, so the first one. So this first term will be equal to what? What is the omega dt?
Acceleration, angular acceleration.
So it will be alpha. So it will be to the term that we are familiar with, alpha cross of S of A with respect to B, no? So we are familiar with that term. Now, plus omega cross, and now comes the problem again. This would be d dt of what? X prime a I plus y prime a j plus z prime a. Okay. Now, what's going to happen when we take the derivative of that one?
You'll get VB.
I mean, we get alpha cross S of A with respect to B. So let's do one by term. Will be plus omega cross. So let's do each one of the terms, I guess. How can I do this? Yeah, let's do one term will be omega cross what? D x prime A dt I plus d y prime a dtk plus d z prime a No, this is J, sorry, J, and the last one will be K. Let's put here brackets. So I've done more space plus. I'm gonna go to the line, otherwise I'm gonna put too much stuff on one line. The next one will be what? X prime A di dt plus y prime A dj dt plus z prime A dk dt.
That's velocity.
So what will be the first term? All this term is equal to what?
That's just velocity. Isn't it?
The velocity of what?
A with respect to B.
Yes, I mean, same as before, no? This is velocity, x prime, y prime into the B reference frame. And this one, we did it before. I mean, what should be this one? So we get omega cross B of
Omega
A
cross
with
S
respect
A
to
B.
B
That's the position, isn't it? Omega cross
plus
A B.
omega cross.
SAB.
So it should be omega cross S of A with respect to B. Is that what we have, no?
Yeah.
So basically at the end, I can say, I'll just go to the next page, okay? So combining. Again, the derivation is not important that you understand it. It's important that you understand at the end of the test, okay? So let's start over here. So remember we have this one, no? So acceleration of A. The first term is what?
Acceleration of B.
Acceleration of B. So let's start by the term we are familiar. So we have this one that we are familiar, no? What should be the next one? I mean, let's put all of them together. Next line, this term should be equal to what? Acceleration of A with respect to B plus cross omega cross velocity of A with respect to B. Yes, this is the second one. Now the last term we say was equal to what? So the last term has three terms. So what are the three terms? Plus alpha cross S of A with respect to B plus omega cross B of A with respect to B plus omega cross S of A with respect to B. All right. So let's rewrite this. So what does that mean? Let's first write the terms that you're familiar with. So this should be equal to what? Acceleration of B. Let me put one space over here, okay? Plus, let me put this one over here, acceleration of A with respect to B. Plus, let me change the order, alpha cross S of A with respect to B. All right. Now I'm going to put the last term plus omega cross S of A with respect to B plus what? 2 times omega cross
VA, yeah.
velocity of A with respect to B. Okay, so since we're going to use it in 2 dimensions before specifying the meaning of each one of the terms, let's just see what simplification can we do for 2D. So for 2D problems, it was shown. Let's see if you kind of remember that one. What is this one here? What is the missing without term that you are familiar with? We did that derivation. If you look at your class notes, we did that.
Over the square SAB.
This should be equal to minus omega squared S of A with respect to B. If you remember, go back to the notes, no? But we're not going to redo it. Okay, so that, or therefore, whatever you want, so that, then we can write the equation on top, acceleration of A equal acceleration of B plus acceleration of A with respect to B plus alpha cross S of A with respect to B minus omega squared S of A with respect to B. And here books do it sometimes differently, but I'm just going to keep it as it is. So here plus 2 times omega cross V of A with respect to B.
Professor, wouldn't it be
What did I do here?
2 times the entire term of omega crossed with VAB?
It doesn't matter.
Okay.
It doesn't matter. Okay, let me leave it over there. Okay, you will understand when you start doing applications. If you want put a parenthesis, you can, but again, it's not going to change anything. Okay, and it's because when you do the cross product, okay, you will already put the 2 on the omega, all right, instead of leaving it outside. Okay, so here comes. So what I'm trying to see over here is that in blue, you saw I put 2 terms in blue. So the 2 terms in blue are the 2 new terms, no? Yeah. So you're gonna have to add these 2 new terms into this equation when what? When you add this new term into this equation, no? When you have relative motion, correct? So if you see that the distance between 2 points is not fixed at any instant of time, okay, so this is fixed any instant of time. This one is not fixed at any instant of time, no? It changes. So if it changes, then the expression for the acceleration will be what? That one, okay? Which is 1, 2, 3, 4, 5. I told you, you're gonna have 2 extra terms. So again, what is over here? So what is AB? What type of acceleration is that? So as before, if you look at the equation that we had before for the velocities, would be the same thing. So translation, what did I call it before? Okay, I call it translation of B, but it should have been translational velocity. Let's say this one would be translational acceleration to make the difference of B with respect to which reference frame? Look at before this was the fixed, no? Then acceleration of A with respect to B, what would that be?
Acceleration of B with respect to the
Translation acceleration, correct, of B with respect to which reference frame? The relative or the moving reference frame is also called. alpha cross S of A with respect to B. What is that? You should know that one.
That's just the acceleration.
What type of acceleration it is? You cannot doubt on that
Sorry,
one.
the angular acceleration.
No, that is the tangential acceleration.
Yes.
Okay, there should be no doubts about it. Tangential acceleration minus omega cross S of A with respect to B. And this is,
Centripetal acceleration.
so this is rotational motion, okay?
Yep.
The other one is what?
The centripetal
You can call it centripetal, but what did I call it on the notes?
normal.
Normal acceleration to show that it's pointing normal, no? Or to the center. And this also rotational acceleration. And these two here, if I want to be accurate, they would be with respect to which reference frame? Think about it for a second. They are moving, this is rotating in which reference frame?
Within A.
It's rotating between B.
Right.
So will be
That's-
the moving reference
that's
frame, no?
one A,
Or the
yeah.
relative reference frame.
So,
So this is O prime, X prime, Y prime, O prime, X prime, Y prime. And the last term, which is the new one, 2 omega cross B of A with respect to B. Anyone knows the name of that one? It starts with a C. Is the one responsible of the car on the track to go on the left side? No, I'm kidding. But is the one responsible for the hurricanes to rotate counterclockwise, or the weather, when you look at the weather on the map, it goes counterclockwise, no?
that's centripetal.
Centrifugal would be the normal. CO
Is it like Coriolis or something?
Coriolis
Yeah. Oh, God.
acceleration. So that's it. That's enough. Each one of these terms. So what is a Coriolis acceleration? I mean, example, we're just talking about example, but the weather. I never checked that one, but if you go to the south hemisphere, supposedly the water in the toilet is going to go clockwise, no? North hemisphere is going to go counterclockwise. If you look at the hurricanes, why do they go counterclockwise on the north hemisphere, clockwise in the south hemisphere? It's because of the Coriolis acceleration. All right. If you go online, maybe we can go. They have all type of cool videos and the equator, even though I think they are trick a little bit, no? But you can see, for example, if you move to one side of the equator, it goes one way. If you move to the other side of the equator, it goes the other way. All right. The stuff of the NASCAR has nothing to do with it. Maybe just for your knowledge, why? Maybe you don't know this stuff. You don't need to know this stuff. But why in some countries, for example, the races go clockwise and other ones they go counterclockwise? That comes from horse racing. So what do you think? They wanted on some countries they go left, on some other ones they go right. It's so just for example, like for example in France, the start between France and England. Okay, they did not want to have their horses to race in both sides. So in England they started to go left, since they drive left also because they want to have the side of the sword free. No, that's why they drive on the left side. So they wanted to go left, the horses to race left. But the rest of Europe, they say, okay, when you come to our races, you're gonna have to play our rules. They go right, no? Okay, I think that's why here they go left, no, the NASCAR. There's no reason why they go left, no, they could go right. For example, helicopter blades. US built helicopter blades go counterclockwise. How do you think go the European helicopter blades? Clockwise.
Just because.
Just because, you know, it doesn't matter, not really.
Yeah, it doesn't matter. It's rotation.
That is little, I don't know.
Even if you do some shooting, precise shooting, rifles, when the bullet goes, how do you think they go out in the United States? Counterclockwise. How do you think they go in Europe? Clockwise. Okay.
There's just insistence on just like, man.
Yeah, I mean, it doesn't make, I mean, actually, the truth, it is better in the northern hemisphere to shoot with a clockwise barrel than a counterclockwise.
That's true.
Because the clockwise will fight against the Coriolis acceleration. Okay. Yes,
Can we just say Coriolis acceleration is relative acceleration?
no, because relative acceleration is the A with respect to B.
Yeah.
That's the relative acceleration in translation.
So can we say it's rotational relatively? Rotational.
I mean, if you think about it, okay, the real definition, if you think about it, is due to what? The Coriolis acceleration is due to the rotation of the Earth with respect to an object that is moving in the air. So for example, why do you have that? Is because if you look, if you are the observer, the object, the molecule of air is moving with respect to the Earth, no? Point B. But the Earth is rotating an omega. So this is creating a force, okay? So if you look at, I mean, since we're talking about it, this will be creating a force. This is the right-hand rule, no? So you have the vector K, a velocity vector. This one will be pointing in the opposite direction, no? So that's why it goes left in the northern hemisphere and it will go right on the right hemisphere. So I would just call it Coriolis acceleration, okay?
So if we were on like doing dynamics on a spacecraft that was not within Earth's gravity, would that term just not be there?
The thing is that
You're still
depends,
moving.
you will still be rotating or moving with respect to something, no?
Okay.
Okay, the stuff when you are on Earth and becomes more complicated is then gravity, okay? The acceleration is equal to gravity. Actually, somebody wants to work on it.
Although,
Nobody has solved anything like that. It's something, okay, let me stop the,
But if you're working on the equator, right, the Coriolis effect is,
should not be
it
Coriolis
shouldn't
effect.
be there, right?
Should not be.
But if a lot of orbits aren't directly on the equator, they go back and forth. So the Coriolis
Yeah, but I
effect
think
is-
over there, the problem is then, how do you account into gravity? I don't know. I don't know. So for example, something, if you do some shooting, which is people don't understand, this equation should work, no?
Mhm.
But if you do some shooting, is something called the rifles or the huntsman rule, which is if you shoot uphill or downhill. If you use this equation, you always overshoot your target. Okay? Nobody knows why. I know it sounds silly, but it's like you think it's the acceleration, it's just a matter to rotate the coordinate system. Okay, so mathematically, it has to do with that. But when you do the real application, you overshoot. I mean, you overshoot if it's big enough, you're gonna hit it, no? But you have the tendency to overshoot it. And I think it's because the way gravity acts. Everybody I tell you that gravity is constant in the atmosphere, I don't think so. Okay.
Constant all over the earth.
That's what they tell you. The reality is a different one. My guess will be, okay?
I mean,
Experimental stuff will tell you that gravity is not the same everywhere.
minute changes in gravity.
And even in direction.
Yeah.
Not even in magnitude, but even in direction, okay?
I literally just said gravity is not the same everywhere.
Okay, good. But anyway,
Anyway,
so let's stop the lecture over here for now. I don't think we have time to do problems.